Um, okay, sorry about that. It was included in IE3. And one of the downsides of all that is that the guys at Netscape were having breaking changes with the people over at Microsoft. So they realized that what they need to do is back when the browser wars were real big, they need to figure out a way to be able to make it so there's a standard. So they don't have to worry about this constant thrashing between browsers for people who are building web applications back in '95. So to do that, November of '96, Netscape submitted a ECMA 262, which was a proposal to the association to standardize JavaScript. And it obviously took a while to get its name. It was at one time called Mocha LiveScript, but JavaScript was actually stuck. Let's take a look at the timeline. We're talking about ES6 right now. ES1 happened in '97. That was when it was formally approved based on that specification that Netscape filed in November. ES2 is a small change. I don't know the exact differences between all of them, so I kind of give you a little history here. ES3 happened in '99. ES4, funny enough, sometimes when they make proposals, it doesn't always work out. So that actually got abandoned. ES5 happened recently here in 2009. So you look, there's almost a full decade of nothing, really, for the most part. And that was pretty much the introduction of the script keyboard in JavaScript. ES6, which we're talking about today, was filed in 2015, and it has been approved. There's a lot of vendors still chasing to be able to bring in all the functionality for them. And ES7 is currently in progress. So this talk will cover less about the history and more about the functionality of ES6, but I just want to give you a background there. So why you're here, you're probably here for a lot of different reasons, but for me, the reason to build and learn a new language really falls in line to the Innovators Dilema. And so there's a couple books about that. There's concepts of innovation debt as well. And the big motivating factor, I think, is you never know it's too late to be able to learn something until it's too late sometimes. One of the great reasons I can think of for being able to spend efforts into learning new languages is talent retention. So a lot of people when they work at organizations like maybe you're here today, you're looking for something that will give you an opportunity to learn something new. And I think that doing that as part of an organization is a fantastic strategy, especially for keeping top talent. Looking at if you kind of break this into two polarizing areas, and maybe they're not as polarizing as I'm illustrating here, but for startups, it's a competitive advantage. And so startups going to be a little bit more, a little bit less risk averse actually. So they're willing to take on new technologies that maybe aren't as mature, and with the idea that they bring business value, but at the same time provides a competitive advantage. That there other people in the marketplace for doing what they're trying to do just won't be able to handle. For the enterprise, it's less about competitive advantage, although I think that's an aspect of it, but in a more mature or cautious environment, it's more of an evaluation of total cost of ownership. And so understanding that moving to a new technology is captivating. It's usually done so by weighing and taking a look at cost and understanding the advantage of just flying directly inside of the customer. ECMAScript. There's a couple different containers, targets that you can run this stuff in. But the first one is the browser, right? So running ES6 in the browser, a lot of times you're going to have problems. You have to worry about people running old versions of the browser, but it is definitely a place for you to be able to take this new functionality and leverage. One thing that allows you to be able to backport and to use the browser, even with older platforms, is using Babel. So I'm not going to go into as much detail about Babel in this talk. Instead, I'm going to focus on the server side, really for the most part. It's more controlled environment. Allows you to be able to do things that are natively available. But when you are taking a look at the server, I'm usually talking about Node.js as a back-end implementation. There's probably some other interpreters if you lay out the JVM, for example, that would also provide you with that ability. But for the most part, I'm just talking about E8 or running some Node interpreter in JavaScript. If you are running Node.js, you'll want to make use of the Harmony flag. I found this out when I was doing a lot of the examples today for everything, is that it's not quite there as far as being implemented in full. So some things are in process, and you'll see that there are a ton of different Harmony flags. So things that have been completed may not be an option. Things that are still progress, maybe in a beta stage, are going to be with this -- Harmony flag when you run the actual node process itself. You'll want to make use of the declarative new strict syntax that came in with ES5. Otherwise, a lot of this stuff just isn't going to be able to be executed, at least on the back end portion of the Node.js implementation. Let's talk about module adoption. So who out there is implementing ES6 right now? I think you could look. Okay, excellent. In addition to some people in this audience, which is fantastic, I am actually curious, since that did get to the process of the straight to the less probably a little bit of a rhetorical question. Who is currently using features or functions of ES6 right now? Right, so a lot fewer hands as expected. From a module standpoint, things that you could use today that have support for ES6 include parts of Mongoose. React definitely has ES6 support built into it. RxJS, so React Native as well. Gulp, so if you want to write your scripts, I think Brent probably has support as well. And then also Angular has support for ES6, especially their dependency injection framework. So there's a lot of big players that are committed to leveraging ES6 in their implementation. Development resources. Who are the targets? The people. So newbies, obviously. So people that maybe are learning JavaScript for the first time. Great opportunity for them to, while they're learning a new language, learn the start from the beginning with a new feature set. Framework developers. So you guys over it, obviously, everybody running the V8 runtime for nodes, kind of knows stuff, but framework developers, people who are building usable components that are out in the web. All your node packages, for example, would be wanting to learn how to do this. If you're writing an Angular framework or something like that, you want to know how to be able to leverage this, obviously. There's going to be a lot of the functionality. Some of this backend stuff that I'm not going to cover enables them to do some things with a lot less code than you would have to do. And really everybody. So I think that learning, as far as ramping up and learning the new features, I think is something that everybody can directly use in their JavaScript today. And that's the upside of languages. It's not necessarily taking advantages of functionality that didn't exist before from an implementation standpoint, but more making some of the things that you do day to day a lot easier, a lot more diverse. So the simple lang is a concept. This is a concept that CoffeeScript, TypeScript used, but it's also, I think for a while there was this idea of like domain-specific languages, DSLs. The same kind of concept is applied for the simple lang. So CoffeeScript and TypeScript are examples of a terse language that is parsed, compiled, and generates JavaScript underneath. And really, frankly, it's that terseness that drove a lot of the functionality that's available in ES6. So it's awesome that that happened. There's still some things that currently aren't there. One of the upsides of bringing it into the language, obviously, is the language providers or VM providers can go ahead and do that a lot more than it would be if you were generating JavaScript and make those calls as well. Also, the other upside is that you would have to bring in the introduction of another language instead if you work directly with the core language itself. So it's first, like I said, makes it so that you have to write a lot less code. There's a new class approach, which is really cool. So CoffeeScript has the concept of the classes. We're going to go into this in a lot more detail later on. But also, there's a lot of really good parts, I think, that come out of the little lang / improvements in ES6. In the little lang scenario, the downside obviously being with the code generation is that you may get some strange interoperability where you're writing CoffeeScript and then you're writing JavaScript and vice versa. There could be some, it's not native obviously, whereas the language platform is, as opposed to generating JavaScript to do the things you want to do. So those are some of the trade-offs of that. But obviously, there's a lot that goes into having to make the language change. So there's a huge benefit that TypeScript and CoffeeScript provide devoid of a new language specification. So I'm going to jump into some code now. There's two new constructs, let and const. So if you look here, this is in let and const. What they have to do is they have to do with variable scoping and mutability. And so here's an example of something that you could write today. It has absolutely nothing to do with any of the new stuff. So we have a variable direction definition A. We print it out here. Then we create another variable and create another variable C. And then we log B and C, and we invoke it. And you can see that because of the way how this is scoped, you have visibility to all those at all the different levels. Yeah, sure. Okay. Okay. Thank you. You guys see that? So, okay, showing here, switching back and forth a little bit. So here you can see what we're doing is so here you can see it's printing out Atlanta, which is A, Austin, which is B, and then Nashville, which is C at the different levels. By contrast, if you look at this definition here, we use the let statement. So the let statement is very similar if you're familiar with Java. It's the same type of scoping that applies to variable definitions inside there. So it's all block scope. So this let A is going to have visibility even down here inside the function because it's at the outer level of the scope. And then we define B here as Austin and C here as Nashville. We'll still have visibility to D here, but you'll see right here when we get what happens when we try to use C outside of the if scope that is defined right there. You see C is not defined. So the upside is that that you cannot access variables that are inside that scope, unlike the bar definition for variable assignment. Move on to another example here. So here what we're going to do is you can see I've got let A and let A. I'm going to define it again. One of the things about the let keyword definition is that if you try to create another variable at the same scope level, it will blow up. So here you can see it blew up on Dallas. So just to show you that it's not just global scope, but also the same applies for the other ones. Here you can see that it's going up here to see as well. So let's move on to a couple more here as well. So In this scenario, what we're going to do is we're going to have a variable and we're going to have be defined. And we're going to go through here. The big thing that I want to show is what happens to not just the variable assignment and the visibility, but also what the side effects do. So here we've got A and B at the top. Here we define A, and then we let B, which is considered different scope. So there's not going to be a collision. Then here we define value for A as well, and another scope inside of a lower level, and we'll see what prints out. So we can see here that in the lowest scope here, A was printed out, and its value was Roswell because it was overrated, and B was Dallas in that scope. And then the next one here, which is the functional scope, we can see that A is Roswell, even though it was assigned to Macon at the top, but we can see that B is Houston because it's a let statement. Same thing then going down here to the outer scope here, we can see that Atlanta is still A, and Austin is still B because of the functional scope. Let's talk about consts. So consts are just what you would think they would be, the constants, but they're immutable. So you don't have to worry about the variables changing or the values changing on them. So show you an example here. I created a constant with a value of 0.12, and what I'm going to do is I'm just going to do a simple multiplier on that. Let's see, these 0.24, just like you would think it would be. So let's look at another example here. So you don't get to do that, but afterwards I'm going to attempt to mutate the constant that I defined. And you can see you can assign to the constant variable. So the interpreter protects those variables for you and make sure that they are mutable. Next up is destructurizing. So I think destructurizing takes an influence from Python or some other languages where you have multiple variable assignments and mapping, which is pretty cool. One of the biggest things that is useful for this is parameterization. So a lot of times when you're defining the parameters for functions, maybe the first 5 to 10 lines of that, if you're building something really robust and used by a lot of different consumers, is that you're going to spend a lot of that time just parsing and switching and shifting the arguments array around. So this new syntax allows you to be able to do a lot of that manipulation baked right into the language. There's probably some other stuff that you can do to be able to move that stuff around. Probably do some mapping or parsing with some other utilities. Maybe do something with underscore, but it's pretty powerful. The other thing that's great for is just deconstructed assignments in general. So if you have a value in an object or array or some other structure, and you want to pull that out into something else really quickly, you can easily do that. The other aspects of destructurizing that specifically have to do with the idea of a rest, which is like a ... a spread, and let's get into some coding examples just so I can show you. So if I try to run, I think my first one here, it's going to blow up. And this is because I need to use a particular harmony flag. So if you're running Node and you want to know what the EA options are, you do that. It's a huge list. It's enormous. So you go ahead and run that and then grep out the harmony tags or options. You'll see it's far less. It's still quite a bit here, but you can see that the ones with the parentheses with in progress those are the ones you're going to need that option to be able to actually run this functionality. So in these code examples, I put that in comments here at the top. So here we go with this first one. You can see it parses it out successfully. So let's take a look what's really going on here. Is I'm able to do, once again, also another important thing is the use script at the top. You'll see that. But I can define an array definition with 3 values for the variables A, B, and C. And then on the right-hand side of my value, it'll then go destructuring it will allow me to then pull those into the appropriate variable assignments. And so here you can see it knows to parse out that array function, that array to the values A, B, and C. You can actually skip bars too. So let's say I have some garbage in my second index in Austin, and I want to skip it. I can just put a column in there. This will work as well. So here we can see both Atlanta and Nashville got assigned appropriately. Yeah. Now here's another example. This is the REST operator that I was talking about. So the dot 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 at the end will autofill that into an array. So just think of this as a variable R that you want to put in, mapping into Java that goes to an array. No different here. JavaScript does the same concept. So here we can see I've got Atlanta, Austin, Nashville, and Charlotte. And we'll run it real quick. And you can see that B is in fact an array, and the values for B are what's rest. Austin, Nashville, and Charlotte. So we can actually take this even another level too, and use destructurizing to compute out the variable names mapping into an object. So here we can see I'm looking to set city and car into this object. And this isn't ordering. This is actually matching on the names themselves to the variable name, which is pretty cool if you think about what's going on inside of there. And then it's able to pull that out. So here you can see city is Atlanta. All right, so in the nature of full disclosure, I'm going to give you an example one that fails. Unfortunately, default parameters aren't supported right now in Node. I did look up and found out that they're actually doing updates on this right now for 5.x. But if this were to work, this would be the notation that you would use. So for default assignments, you do an equals and then the value for each parameter value that you have inside of here. So, I'll show you it doesn't work. There's a lot more than what I've shown here, but it's 75 minutes long, so I can't go into all the details. But there's a ton of stuff that you can do, obviously, with these structures. Object literals. Object literals are a shorthand notation for doing a lot of the same things that you would do for object construction. So let's go ahead and let's talk about some. Let's see some of the examples here. So here you can see I've got, this is the traditional way of building an object. So here you can see I have a value of x and I have a value of y. If I want to create an object that has x Atlanta, y Houston, that's how I would do it in the old way. And here you can see there's Atlanta. The new way of doing this is that you can have, instead of doing attribute colon value for your object construction, you can just say the variable name. You'll know to map that into that being the name for the value into the object index. So here you can see it's the exact same stuff that I showed in the last one, except it's just obviously a lot shorter. think of this as object literals as the opposite side of deconstructing. All right. Arrow functions. So that's the notation, and that's the code. Arrow functions are with radius closures or closures. It's anonymous closures. It's a real lightweight notation. The existing way of doing anonymous functions in JavaScript is, well, I'll show it here, would be used to define a function value. So in this case, you can see that there is no function definition of variable name. Instead, it's the parameters, the arrow, and then the implementation. So this is essentially the equivalent of saying calc equals function amount rate, and then the implementation directly underneath it. So let's go ahead and run this guy real quick. And you can see 23 is calculated appropriately for it. You can do it even more shorthand than that. So this is a one-liner for it. So if you don't do the curly brackets around it and you do it on the same line, you can put your statement directly here in line. Same execution. Very, very simple and lightweight. Template strings. So this was I do a lot of string concatenation, templating, and usually I'm able to, if I'm building a web app, I can throw something in the handlebars and push that type of templating into something else. So it's nice to be able to have this directly in the language. So real quick. So here's the top version. You'll notice that this is the what is it, the accident character, the one right underneath the tilde. Same one that you would use if you executing a bash command or something like that. My Sublime syntax highlighter doesn't know what to do with this, but basically these are essentially the same. It's the creation of two strings. One's using this special notation, and the other one's the old school way. You can see they're equivalent. They look the same. They print the same. Everything else. Let's take a look at template strings. So let's click it a little bit. So here, what I'm doing is I'm creating a rich string. So traveling from origin, which is a variable declaration up here, to destination will take, and I'm actually doing the calculation in line inside the actual string itself, hours. And there you go. So obviously you could do formatting inside of there, whatever else you want to, but the idea behind this is you don't have to concatenate. The other thing that's really cool, in addition to that, is dealing with multi-line strings. So here's an example of something that I want to have across 3 lines. So this is a multi-line string. When I run this, you can see it prints out multi-line string, which is pretty cool. Collections. So new for JavaScript is really weak references and some robust collection frameworks in addition to iterators to be able to work with them. The symbols. We'll get to those other two aspects real quick. But real quickly, the new collections, before, if you want a collection natively in JavaScript, you had an array or you had an array. That was it. So the cool thing here now is, in addition to having a rich collection aspect in the actual API itself, now you can actually work with weak references. So this is great if you are working with a cache or you're creating a ton of objects memory, the GC will take care of it for you once those references to those individual objects go out of scope. So that is really, really cool, right? So if you want to do something that's really, really highly scalable in-memory caching inside of your Node.js VM, then you can completely do that right now with the question framework. So here we are, I've created a set, and so what I've done is I've created a set. This is now a weak reference set at all. I'm adding elements hello, goodbye, and hello, and let's take a look and see what's inside here. We should, if this is correct, only have two elements when we're done, because the set is defined as a unique set of entries, but it's not key. There we go. So it's implemented like it should. Maps, on the other hand, same concept. So here I'm creating a map. I'm creating two entries. One with the key of hello to value 42, one with the value with a key of key with a value of 34. And here we go. You go ahead and here you can see I've referenced those values as well. So there you go. We've got two accessible entries inside of the actual set of map. Now here's the weak map. This is a little bit more challenging for me to demonstrate. So I put a timeout in here and moved it out of scope. But what we're doing here is we're creating a complex key. So keys have to be objects. They can't just be a string. So it seems kind of goofy that I create an object with just a string value inside of it, but that's what I had to do to be able to construct my key for the weak map. And then the big thing is that your references to the key. And that's how you get the value. So if that key is destroyed or dereferenced here, I said it's null, then the GC should come in and wipe out that reference from the weak map. So here, if everything goes right, we should have a value. And here, if everything goes right, we should have a value. There you go. So it's undefined. So it does its job. I need to go through an example here that you can do weak sets as well. Symbols. So symbols are kind of cool. They were really, really needed for some of the iterator stuff, generators, etc. But symbols are a way for you to define constant and not have to worry about passing strings all over the place. So you do faster lookup, they do faster definitions for members inside of your objects that you're constructing as well. They do it in a way where you can reliably use the same constant, whether or not you have scope to something outside of two completely different implementations, so two separate functions themselves. So let's go ahead and take a real quick look at symbols. So here you can see what I've done is I've defined a symbol called name. And I did an assignment to full name as well, so this should be the same. And then here I create a person, and this is called a computed value. But this is a way how you can be able to reference symbols as opposed to using straight string names for your attributes. So here you can see I'm going to print out person name and person name. It should be the same, and then again, here they should also be the same. So let's look. And there you go. Now here we do a lookup. So before you saw I was creating symbols and assigning it. Well, that's great, but that doesn't do me too much good if I have, let's say, two completely different libraries or two different functions, and I don't want to pass those and expose them globally. I'd like to be able to do the same type of lookup. So you can do the symbol.for. What that will do is it will either create that symbol, it doesn't exist, or return the existing one. So think of it like a common JS lookup or C lookup for your constant values. So you can see right here we're in scope for name and we set down the person object, and then here we're outside that scope, and so we're doing the lookup on that. Both of them should both return Andrew in this scenario. I didn't print out the video. So we assign it here to Andrew and we did look up here. So, we're running out of time. All right, iterators. So let's see if I can go through this real quick. Iterators are like a contract. So the idea behind it is that if you have an iterator, then when you define, and this is just a core implementation. This has nothing to do with symbols or iterators. This is just, if you're writing your own iterator, it would look like this. So we've defined a method called next on this object, and what happens is if we are iterating through it, we got a value that's in there, the value's in there. If it's the last one, then we include a done equals true inside of it. Or if you hit the end, we just keep on returning done. So in this scenario, you can see I've got 1, 2, 3, 4, 5 cities, and I call this 6 times with the last one being done to check that it's done. And you can see that successfully went through. So now, let's take a look at this using the iterator syntax. So something a little more complicated. So you can see what I've defined is I've defined basically a computed attribute with the symbol.iterator. So in addition to being able to create your own symbols, there's some predefined ones that the VM actually creates by default. One of them is called iterator. So if you're what you do in that function is that it is going to return an expectation that there is a next method. That's it. It doesn't. All this other stuff is internal. So stops and next index are completely internal. And it does the exact same contract that we had before. So you can see it returns values and values. What I do is I create a reference to this right here, and then I'm just making the same call as I did before. And you can see that it worked out exactly the same. So that's the concept behind iterators. Obviously, one of the big benefits of doing this with iterators is that you're streaming through a set as opposed to dealing with full collections, which could tie up a ton of memory, for example. So a lot of really cool frameworks like React are using streaming, so it's cool that this was brought into the language features as well. All right, so generators. Okay, so generators are probably the biggest leap for developers to get over as far as the introduction to the language. They allow you to be able to do 2 things. One, in a really, really cool and clean way, iterate through objects. Another one, abstract out potentially asynchronous calls to your generator implementation. So what that means is I can keep on calling something, or I can call something, and it may invoke a promise. I'll get into promises in a second, but first I'm just going to focus on the front side now, which is the iteration for generators. So here we have a generator, and what I'm going to do is I'm just going to yield these 5 cities. If you look right now with how we define the generator with the next.value and the done, this is identical to the simple implementation that we had before. That's the concept behind generators, is that you call this in a way that looks identical. So from generator.next, value, that tells me the value that was yielded here. So here, I'm going to create an access to my generator. You'll notice the star here on this function name. So the star is something that you define in your generator method, and then the yield is a keyword that you use to be able to yield the results back to the consumer. run this real quick. And here you can see we've gone through it twice. So the first time we went through it and we did the direct invocation. The second time we looked, what we did is we created a generator and we used the symbol iterator to be able to gain access to it. Here's another example. So in this example, what I'm doing is, this one's going to fail unfortunately, but I want to show you the keywords. So what the generators allow you to do is, in addition to be able to implement tick by tick through your sequence, you can also tell it to just close the finish. And you can instruct it what value to use in that scenario. And so if this was implemented, what you would see, console log would show you 1. You hit this return value, and it would show you 22. And then this third line would show you done. Unfortunately, this fails. Return is not implemented correctly right now. You can also make use of throw. So on the consumer side, you can tell the generator that you're accessing to throw a value. So here, on the consumer side, this is everything here. This is my consumer side. So what I'm doing right now is I'm going to get the first hit, and then I'm going to I'm going to tell the generator that I'm going to throw a value, and I'm going to throw it again. Then here's my producer side of it. So I define it with this star. I call it yield. I put this in try catch block, and so I get the throw exception of this throw by consumer. Same thing here. I get will throw by consumer. So here you can see it yielded 1, and then it showed me the error that got passed back into it for the throws. So currently, right now, the throw is implemented, the return is not for node. Last, let's look at another really cool idea. So generators support composition. What I mean by that is that a generator can return another generator, but to the client, it looks like it's just iterated through 1. And so in this scenario, I'm going to create generator 2, right? First thing it's going to do is it's going to yield 1. And then it's going to yield all the ticks from this other generator. And then it's going to yield 2 more. And if you use this notation of passing an array of values to your yield statement, those would be multiple ticks as well. So I should tick through this 1, 2, 1 plus 2 is 3, plus another 2 is 5 times. And there you see it. So it goes 1, A, B, 2, 3. I know I'm going through this real quick. A lot of cover. All right. Next one is async callbacks. So callback hell. I've been programming JavaScript for over 10 years, really intensely, and a lot of Ruby developers I would talk to would complain about callback hell, and it was hell. It's pretty brittle. Some of the things that you can do to get around it is use Async.js, which really helps out with doing collections and doing stuff concurrently and working with queues, but it's still pretty much sucks. Let's go ahead and take a look at this real quick. So let's say I create a service. The contract behind doing a Async.js call is that if you're providing a service that is synchronous, you provide your parameters, and then the last variable in your functional parameters are going to be the callback. So just like Lambda expression. And then what calls back into it is going to be a function for your callback. The first parameter is an error, and then everything after that is going to be set of results that are included in the callback. So here, the big thing isn't really to see the execution of this, but just see the nesting of the callbacks. So you can see, here's my first one, and then you can see another nesting. Here's my second one, and here's another nesting. Here's my third one. And you can see that my error logic is not very dry. It's very difficult to make it dry. The nesting of the invocation on the stack is pretty deep. And I've even seen some JavaScript interpreters have problems with too many callbacks, and this callback hell will turn into stack overflow. So I'll just execute real quick just to show you that this does actually work. We've been successfully went through all that stuff, so took a little bit of time, but it's because I've got some timeouts in here. I've got to set the timeout for each one of those calls. So that's the way how it used to be. If you want to do stuff back in the day. Then along came promise libraries. So the cool thing about them is they had functional scope. They were third party. Libraries like Q or Win. A couple other ones out there as well. Downside is that they were non-native. So let's go ahead and let's take a look at some examples of promise libraries. So you're going to see the service that I had here before identical. But now you'll notice that the promise invocations down here at the bottom, you'll notice that they have functional scope. They use .then, and the .catch, where the result from the previous invocation gets returned into it. So if anybody's been developing in JavaScript for the past like 1.5 to 2 years, I knew they were doing promises. I got rid of the async. Q actually has some pretty cool stuff where you can adapt async type style into promises really quickly. And they support aggregation, they support doing concurrent as well as serial processing. Anyways, so let's just run this real quick. You're going to see the exact same results as the one before. So, success. Then native promises came around. So this was really important for the language to implement because native promises could be a lot more effective and provide performance than third-party library would be able to implement. I've been using native promises in all the Node.js implementations that I've been using. Mongoose, for example, if you guys use Mongo or Mongoose for JavaScript, you can plug in with the 4.x versions of Mongo. You can either plug in your own specification of which promise library to use. By default, if you're running ES6, it detects it and you're using native promises. So, pretty cool. Let's take a look. The syntax for native promises is uses the new promise keyword, but it's resolve and reject. It's really simple. And you can see, other than me switching out in the previous example that I had for the third party, I was using Win. See over here. And this one I'm using the standard native promise. Same implementation of one. Second example here. So in this example, what I'm going to do is I'm going to show you that you can actually do aggregation of promises. And so this is useful if you want to iterate through a set of items and then return a promise for the next one so it still looks like the same chain. This is an example of doing that. So you see I'm using underscore to map out or return a new promise for each city that I get back. Then I call promise.all. It's just an array of promises, and that's how they use it. I got rid of the time, so that's why I was much faster. In this third example, you see what's above is the same, but you can see what's down at the bottom, no promises. So really what's going on behind the scenes here is I'm using a generator. So there's a library called code I'm bringing in. It allows me to use generators with promises. I believe that the execution of the promises for collections, which this one isn't, these are just single implications. would be serial, but that is going to be up to the implementation for your interpreter that you're using. The promise construction doesn't really specify whether or not it's serial or it's parallel. But what it does say is that if you hit a first reject, it will abort and it will throw the catch. So something to keep in mind. So in this notation, you can see we took something that was extremely asynchronous and made it seem like it's completely synchronous now. With the added benefit of not introducing or losing any of the cool stuff that JavaScript is known for. So your REPL loop still is completely secure. The generators are provided what appears to be a blocking call. So here you can see I'm making calls to connect. You'll notice that my connect up here at the top is a promise, and it results null, so I don't have a value. Then you see, and then it should connect. Afterwards, then I make another call to get city. You'll notice I use the yield syntax in front of it. But here you can see I have a value. So what it's doing is it knows that whatever is in that resolve call for your promise is what's going to be implemented. So here, this is what's going to be my return value when I invoke it. Then it allows me, then I'm just going to go ahead and change the value on that and then call an update to the service. So let's take a look here. Using this underneath, you can see I got 4 seconds, 100 millis, and then a 3 second width. So this should be about 7.5 seconds. There you go. So pretty cool syntax to be able to invoke using generators and promises together. The last example here, I wanted to show you that it's possible to use sets with generators and promises. One of the critiques I heard from the person that I worked with was that they wanted to wait on using ES6 with generators because it wasn't very robust from an async standpoint and it didn't support collections. Well, that's absolutely untrue. The same way that you would use collections in a promise implementation, you can use generators as well using code. So here you can see the only thing different here is that I'm getting a result of cities here, and then I'm creating the array of promises, and I'm invoking it. I've reduced the timeouts on here, so this should fly. So you can see it's got the dots at the end because that's what I added to the cities here. All right, so proxies are cool. Proxies are not implemented in Node. I'm going to skip this one because you guys can look at it afterwards. We're running out of time. Modules. Again, modules are also cool. Unfortunately, so there's this concept of AMDs, which were kind of old school. CommonJS came out with their own notation for doing module loading, which is really, really awesome. And then the new ES6 allows you to be able to have enhanced exports and enhanced imports. So you can say, of this library, I want to import this particular export into a variable assignment using deconstruction. So I'll show you what that syntax looks like real quick. This is what it looks like. Here you see I'm importing off and city service from a module that I created. And here's my module. You can see at the bottom. That's where I'm exporting to variables that will be available for my implementation for my module. Like I said, unfortunately, this one's not working. Classes. All right, so I'm just going to jump straight into the code. But classes are new. So classes existed if you did anything in CoffeeScript, but they're new for this. So first of all, if you're going to implement something, this is how you can create an object that has a function called same name on it. I'm not going to go through it, but basically, when you call same name, it's just going to say hi on the answer. Then there was this concept of prototypical definitions that you can do. So you would define your, since it's a little odd, but if you want to define the concept like type or a class, it would be a function, and then anything that was available as function name prototype, and then export everything that you want inside of that. Here you will, the benefit of doing this way is that you can change, you can instantiate person 1 and person 2, change the implementation of the same name later, and it would be cascaded across all the objects. And this is the way that a lot of people implemented libraries. It wasn't the way that I did it. So a lot of times when I would do something, I would stay using prototypical inheritance or for extensions, I would go ahead and use this approach where you do object extension. So you can see in this case I define a person, and then what I would do is I would extend it, and I would just put a constructor so that I can construct that object however I want to. But the downside of these obviously is that I think this occupies more memory, but it's much cleaner from an implementation standpoint for supporting your code base like that. Now, that's kind of, I'm not going to show the example of it, but that's kind of the old way to do it. The new way to do it here is this new class keyword. So you define a constructor, and then you define your method. You notice I don't say function or anything else in here. I just define the method with the parameters on it, and it'll automatically invoke that. And then here I can do the construction of that person. So I'm going to click. You can see here's an example using get and set properties. So one thing that's also new is the ability to use getters and setters. And so this is this provides a facade. So I'm going to store, instead of calling my attribute name, I'm going to name it underscore name. And you can see here that you have a getter and a setter. And because I'm printing out whenever you set it, whenever you get it, we should see that here in this assignment. And here, we show it. And there you can see the setters and getters being captured. You can also do status. So if you want, this is a poor example, but it's still an example. In this example, all I'm doing with my static method is returning to the uppercase. Obviously, this would be kind of cool if you want to implement like an active record implementation where you do dot and then you look up or something else like that. But here you can see Joe should be in all caps after I go this. And Joe's in all caps. All right, I've got one last thing we can wrap up. Here is an example of inheritance. So I've got a person, I'm going to say user extends a person. It has a different constructor, and I've added a method called checking on it. So here I'm going to create a new user, and I'm going to log out name, which we should see the same getter setters because it's the exact implementation. And then when I do a check-in, you should see the check-in. There you go. Future. All right, so ES7, which is the next thing, some of the stuff that is going to have are class decorators. So if you're from the Java world, that's annotations. It's kind of a cool concept. It's going to have class properties, which are a little bit different. So you can think of this as almost like some more reflective stuff. REST and spread are going to be able to be put onto those properties. And there's also typed objects. To me, typed objects is a sad thing for me. I feel like it's violating typing and everything else. But anyways, it's there. The bind operator. Think of this as like doing mix-ins to be able to add stuff to functions. Pretty cool. It's a great way to be able to get away from inheritance. And then the sync functions are going to be really, really tied into it. So you see the sync keyword and a bunch of stuff, which is making that first class, which I think is really, really cool. If you want to learn more about this, a book that I have that has some of the examples that I went through in here is in this book, Learning JavaScript. There's also ES6 and beyond. Unfortunately, those are the only two books that I was able to see. There's another one that somebody from O'Reilly is writing, and I looked at that, and it had zero implementation for chapters, unfortunately. You can always go to the ECMAScript source. It's an ugly website, but it's full of content. I suggest taking a look at some GitHub resources on ES6 features and also compatibility tables. Just to let you know what browsers, what server-side frameworks, etc., are implemented, what state they are for not just ES6, but all the breakdowns of individual functions that are available for the language. I know we ran out of time. I'm around here to answer any questions for anybody who'd like to come on up. My Twitter handle is Zuercher. I'm going to post up. You can take a look at this now, but I'll post as soon as we're done here with the talk. I'll post and tweet out the PDF that was here in the talk, and then also the link for this GitHub account, which has all the samples I just went through. And if you want to get in touch with me at all, send an email to info@Babel. But otherwise, thank you very much. I appreciate it.
It's actually heavy. Yeah, the only thing is here is that multi-line. It's kind of cool, right? That would be an example. Or, okay. There's only if you explicitly want to use that. And that's fully, yeah, absolutely.
Has it been, man? Just going to grab your slides. Or...
All my slides?
Yep.
How you been? I heard you're over at the Depot of the Homes. I heard that you got promoted.